Hello, I'm Muhammad Sulaiman. I'm a mechanical engineer. Today I'll be giving you an introduction to statics. Statics is one of the basic courses given to engineering students. It's a fundamental way of studying the stability of structures. Statics is a branch of classical mechanics. It's a study of the equilibrium of rigid body, which means that the bodies we're gonna face through this course are considered undeformable. And we're gonna focus mainly on bodies that are stable, that are at equilibrium, not moving. So there will be no interest in the acceleration or velocity during this course. The basic quantities used in statics are length, time, mass, and force. Each one of those quantities has its own use when solving statics problem. Length is used to locate the position of an object and describe its size. Time is a succession of events. We might define a time or moment when force is applied or is removed. The mass is the measure of inertia of bodies. Forces are the main quantity to find through this course because force acts upon an object and define its state. We may distinguish push and pull forces, which are known as compression or tension. Before solving statics problem, we need to make some assumption so the problem solving will be simpler and easier. Those are idealization. We're going to assume each body we encounter through the course as a particle. So the mass is concentrated at the center of gravity of a particle. We define any body regardless of its size using its mass and its center of gravity. Second, we are dealing with rigid bodies. The rigid body is a combination of particles, so it's undeformable. Therefore, through this course, we're gonna not take into consideration any material properties because we are considering that bodies are not deformed. Finally, we're gonna assume that the force is concentrated, so it's applied at a specific point. Now, before proceeding to the physics part, we need to have some preliminary math knowledge. First, we need to distinguish between scalar and vectors. Scalar, which are numbers and quantity, represent magnitude only. Vectors are magnitude with direction. So there is a difference between them. You shall be familiar from math with the notation of vectors. Vector, which is a segment with an arrowhead. This segment has a specific direction measured by the angle theta. It has a sense expressed by an arrowhead. It has a length or magnitude, which shall be always positive. We may distinguish between positive and negative vector. The negative vector, which is in this example minus v, is just to express the direction of the vector. It has nothing to do with its magnitude. So when we say minus v, it means that that's the vector having a direction opposite to v, but with the same magnitude. You shall be always familiar with the vector operation. As forces are always represented by vectors, you need to have the vector knowledge before proceeding to the physics part. You need to be familiar with vector sum using the parallelogram law or triangle law. As you might see in this example, adding two vectors will lead to creating the diagonal of a parallelogram with the sides are the first and the second vectors. The vector subtraction is similar to the vector sum. The only difference is you are adding the opposite of a vector. It's like making v1 plus minus v2. So you'll just flip the direction of v2 in the sense you can get the subtraction of the two vectors. Also, you need to have some triangle relations knowledge. One of them is the cosine rule. It's a very powerful tool to use. It relates the magnitude of two sides with the third side and the angle between them. It's a very powerful tool. Also, you need to be familiar with the sine rule, which relate the sides of a triangle to its angle's sine. You need to be familiar also with the vector representation. We might replace the vector notation with what's known as unit vector. The unit vector is a useful expression of vector direction, so you can see its orientation in space. Through this course, we're gonna see the rectangular components, which means that the vector can be the sum of two other vectors. So the vector is just a resultant of the sum of two other vectors. In order to make a good representation of those vectors, we will use the notation of unit vectors. Unit vector is a vector that has the same direction of the original vector, but it has a magnitude of 1. So we're gonna express the original vector using this unit vector. Other operations to be useful through this course are the dot product of two vectors. Remember that the dot product of two vectors is known as scalar product. It will lead to having a scalar, a number, and not a vector. We can find the scalar product either multiplying the magnitude of vectors by the cosine of the angle between them, or we can use their component with the notation of unit vector, as you might see. In this example, the vector p is expressed as function of different unit vector. It's the sum of three components along x, y, and z, and three unit vectors I, j, k. Another vector operation is important, especially when finding the moment of a force, which is the cross product. The cross product or vector product will result in having a vector and not a scalar. It's different from dot product. It will lead to getting a vector that's perpendicular to the original vectors. We can find the cross product either multiplying, it's the magnitude of the vector resulting from the cross product, by multiplying the magnitude of vectors by the sine of the angle between them, or we can use the Cartesian coordinate of two vectors to find the cross product. The difference is using the Cartesian coordinate of two vectors, we can find easily the direction and sense of their cross product. So it's a very powerful tool. Now we can move on to the physics part. In statics, we mainly rely on the first law of Newton that states that if a particle is originally at rest or moving with constant velocity, it will remain in its initial state provided that this net sum of forces applied to the particle is zero. So if all the forces are equilibrated, they will sum up to zero. They will not make the body move. The second law of Newton that states that the sum of forces applied on a body, if it's different than zero, then it will make it move with an acceleration a. And the third law of Newton states that that if body A is acting on B with a force Fa on B, then B will respond to this force by creating another force FBA, which is opposite to the force of AB. It means that the two forces have the same magnitude, the same direction, but opposite sense. It's known as action-reaction. In this course, we will use mainly SI units. There are other unit systems. The unit system is very important because it defines the order of magnitude of the variable or physical quantity we are computing. The SI unit mainly rely on Newton, kilogram, meter, and second. We might see through this course a lot of units and their conversion, the kilo, the millimeter, in millimeter, it's 1/1000, the kilo, which is 10 to the power 3, the mega and giga, they are not very used through this course, neither the micro and nano. Thank you for your attention.